Sampling is an age-old practice. We all of us practice sampling, not knowing that it is a huge science. Only during the last few decades, we have found that sampling is a big theory. We all practice it because it is convenient, it is less time consuming, less costly, and that is why we practice this sampling method whenever we are interested in large scale buying or large scale selling. If I go to the market to purchase a bag of rice, I don't have to look into every particle of rice to find out whether it is of the required quality or not. I just examine a sample and decide that the bag must contain the same quality. Similarly, a man selling some bales of cotton to a buyer cannot expect the buyer to look into every pinch of cotton in the bale to find out the quality of cotton. Large scale buying and large scale selling is possible only through sampling. There are certain other situations where sampling has to be done. Today we have extended this theory of sampling even to measure the parameter of the universe, a measurement of the universe through a measurement of the sample. Say, if we have the sample mean, we try to estimate the mean of the universe. But the question that is always before us is that we do all this with a strong belief that if the sample is a random sample, then on average it has the characteristics of the universe. And also, the larger the sample size, the more nearer are we to our belief. But would it be possible to practice sampling in every situation? It is not so. Can we rely on the sample completely to determine the characteristics of the universe? Certainly not. We have to see that we adapt ourselves, or we use the adapted method of sampling and make more a scientific approach, so that sampling techniques have got to be used in order to see that the sample becomes more reliable to represent the universe. So let us discuss the various techniques that we have to make use of in sampling in order to see that sampling becomes a reliable tool to see or estimate the characteristics of the universe. We make use of three broadly categorized methods. Number one, we say probability or random sampling. Number two, we say judgment sampling or subjective sampling or purposive sampling. Number three, we say mixed sampling, the mixture of the first and the second methods. Let us study these different techniques that we make use of one by one. The first one, simple random sampling. What does it mean? We take up a sample at random and examine this random sample by certain methods. The first one, the popularly known the lottery method, where we make identical chits or identical cards and then name the individuals according to the numbers that may be there on the chits or the cards, and then pick up samples one by one so that we make use of the lottery method in order to pick up the required sample. But this method becomes cumbersome the moment we find that the sample size is very, very large. And it is difficult to use this particular method. Therefore, we go in for some other method which we call as the random table numbers method. We find Tippett's random number tables, Kendall and Smith random table numbers, Yule's random number tables, and so on, which help us to pick up the required samples by the use of these random number tables. On these random number tables, 4-figure or 5-figure numbers are arranged randomly, and then what all we have to do is open a page at random and take up these numbers either vertically or horizontally, row wise or column wise, and to get the required sample. This method has been found very effective and has become very, very popular and is supposed to give us a very good random sample. If the number is, let us say, only a 3-figure number, then out of the first 4 figures, we omit the first figure and take the last 3 numbers. Similarly, if the size of the universe is less than 100, then we take the last 2 figures. This is done systematically so that we are able to get the random sample that is required. But one very important factor that we have to bear in mind while we use this random method is that the universe must be finite. We must be able to determine exactly the size of the universe. And the second important rule also is there, that whenever the sample is picked up, it should not bear any kind of relationship with the universe for which the character is being studied. For example, if we are looking at the performance of 10th class students in a school and we pick up 10 schools at random, then we should not think of the characteristic of the performance, but can think in terms of any other characteristic when we choose our sample. That means it should not bear any kind of relationship with the particular character that we have in our mind. This random sampling method, of course, is very convenient and found to be extremely useful, but it has its own limitations. Although it is free of human prejudice or bias, as we call it, yet there are certain practical difficulties in the use of random sample, because the situations in every case is not the same. The units may not be homogeneous, all units may not be the same. So random sampling sometimes becomes totally useless. Therefore, it is necessary to adapt ourselves and make more a scientific approach in order to see that certain other methods are also being employed. Secondly, let us think of judgment sampling or subjective sampling. Here, the investigator's judgment is being made use of in picking up a sample. Doubtless, there is this bias or human prejudice that is involved, but the investigator knows that is the only place where information is available accurately. For example, if we are studying a problem on use of telephones, we have got to necessarily go in for the telephone directory to pick up the sample. We can't do just random sampling including each and every one. Similarly, if the investigator knows that information is available only from these particular individuals, he has to use his judgment in order to include them in his sample. This particular method naturally suffers from human bias. The third one, of course, is mixed sampling. where there is a mixture of random sampling as well as a mixture of judgment sampling. For example, we have, let us say, stratified sampling. That is the third one. Stratified sampling means the universe is divided into groups or stratas using a stratifying factor, and then we select from each group samples at random. For example, if we want to study the educational expenditure of a university student, we can't group all the students into one and just pick up a sample. We have got to divide them into groups, let us say arts, commerce, science, engineering, medicine, law, and so on, and then pick up a sample from each one of them, so that our sample naturally would contain all types of students whose expenditure is being noted, failing which a random sample will not satisfy our objective. Now, this stratified sampling has also certain disadvantages. If the stratifying factor, as we say, is not correct, then the whole procedure of sampling becomes totally useless. Therefore, it is necessary to know how to prepare these strata. Sometimes it is not possible to do it easily. Let us pass on to the third method. Let us say the third method is systematic sampling. What is the systematic sampling? In this method, either the whole universe is arranged in a serial order, let us say alphabetically or numerically, and then the first sample is being picked up at random, and then thereafter the gap between the first and the second and the third being one and the same, we go on picking up samples. For example, if one is a moderator of a certain paper in a university examination, all the papers are stacked up before him and he has to moderate, let us say 10% of the papers. The first one he picks up at random, let us say the sixth one, and thereafter he goes on picking up the 16th, 26th, 36th, and so on. When we make use of this method of systematic sampling, first we are required to find out what is n, that is universe size. Then once we decide this universe size, how much of a sample do we require is to be decided. If we say 10% means 10 in every 100. So naturally, if n is equal to 10, then k naturally will be equal to n by n, that is 100 by 10. Supposing n is equal to 20, then naturally k will be equal to 100 by 20, which is equal to 5, when n is equal to 20, and so on. So systematic sampling involves what we call as this k, every kth item, 2 kth item, 3 kth item, and so on. But this systematic sampling, being so simple and easy, has its own limitation or demerit. If supposing every 6th item we take up, let us say the first item, and then go on 16th to 26th, 36th, and so on, and if that sixth item happens to be a corner shop, then 16th also happens to be a corner shop, 26th also happens to be a corner shop, then what happens is our sample gets a biased picture and not a true picture. It will not become a true sample. So in systematic sampling, there is every possibility of the sample getting biased. Now let us move to the next technique of sampling. That is, let us say the third one is what we call as multistage sampling. In multistage sampling, we go on picking up samples at different stages. For example, we have this country of India first, and from this country we divide them into states first, and then we pick up a sample, random sample, first stage, a few states are picked up. Second stage, from the first stage we pass on to the second stage. From the states that we have picked up, we try to pick up certain districts at random. Third stage, from the districts that we have picked up at random, we pick up certain mandals at random. Fourth stage, from mandals that we have picked up at random, we pick up certain villages at random. And these villages become the core of the sample which we are going to use. So this type of sampling is what we call as multistage sampling. Similarly, we have cluster sampling. The universe is divided into clusters. Let us say Hyderabad city. Hyderabad city is first divided into about 40 zones. And from these 40 zones, we pick up some 10 zones at random as our sample. And make enquiries in these 10 zones. So, what all we have done is divided the entire city into 40 zones, from which these 10 zones have been picked up at random. Now, it is very important that these zones which we pick up must have very few numbers or few individuals. If the number is very big, then it becomes very difficult. Few individuals. At the same time, all the zones must contain same number of items. So this method is what we call as cluster sampling. Then we move on to the next method of sampling, which we call as quota sampling. Quota sampling. Here, quota is determined. Quota is determined, and the investigator is free to pick up samples as he desires, but bearing in mind that the restrictions are there on the quota. For example, if we say scheduled costs must get 30% and then scheduled times must get 15%, backward classes must get 40%, the rest of them only to the forward classes. He can pick up any individuals such that this particular quota does not go beyond what is fixed. So he has his own bias in picking up the sample, but he sticks to what we call as the quota, and that is what we call as quota sampling. Of course, this method is made use of particularly when we think in terms of this election surveys, market surveys and so on, where the bias of the investigator is always there. These are the various techniques that we make use of in sampling. Having studied the various methods of sampling, now let us try to study the errors that may creep up on account of the use of the sampling method. These errors are of two types. One, we call them as sampling errors, and the other we call them as non-sampling errors. First, let us take up the sampling errors. What is an error, in fact? The error is the difference between the true value and the value estimated through the sample. Now, if this error has to be minimized, there are a number of ways in which we can do it. The first one is that we have to use the right type of sampling. If we pick up a wrong sample, naturally the error will be more. In fact, it is necessary that the characteristics of the sample on an average must represent the characteristics of the universe. This we call as the law of statistical regularity. Not only that, the size of the sample must be large enough to represent the universe. Larger the size, the greater is the precision. This being so, it is necessary to avoid these errors by choosing the right sample and of the right size. Sampling errors are due to wrong choice of sample, choice of wrong size of the sample, and sometimes on account of the bias of the investigator. The non-sampling errors arise because of the defects in administration, that is, wrong totaling, wrong labeling, and similarly any kind of what we call as clerical error. Now, these are some of them which can be studied. Wherever it is possible, we can try to avoid these errors, but it is necessary that we have to make use of the right choice of the sample and to see that the right size of the sample is also taken up to get the exact precision that we so desire. As against the sampling method, we know that we have to use the census method or the complete count. Under the census method or the complete count, it is absolutely necessary that all the individuals that may form the census must be known. But it may not be possible if the number is so large. So the census method sometimes becomes impracticable because of the huge size that it has. But in sampling, it is not necessary. Although the size must be finite, but by picking up some small sample, it is possible for us. A diminutive size of the universe is enough in order to make conclusions about the universe. Census method, of course, is more accurate than the sampling method, but sometimes becomes highly cumbersome and highly expensive. Therefore, we have got to resort to the sampling method, and we have already discussed the various techniques that we make use of under the sampling method. It must be borne in mind that this sampling technique is an excellent means in order to obtain information about the universe and is practiced throughout. But at the same time, we have got to have a finite population. That means all the individuals from which the universe constitutes must be formed, and then only we can think of a random sample. Otherwise, you can't pick up a random sample. Similarly, there are a number of difficulties. How to avoid what we call as human bias? How to get the right precision? Sometimes we may have to pick up a very, very large sample in order to see that we get the exact precision that we need. This can be mathematically or statistically found out as to what should be the size of the sample if we require a certain amount of precision. The various methods that we have studied are necessary just because of adaptability and a scientific approach to the subject of sampling. Therefore, sampling techniques are absolutely necessary in order to make them more and more suitable to different situations which we come across in our life.